The Penn State Mechanical Engineering Department has tasked our group with programming a robotic arm. Today, we'll be discussing the video journal of this programming and process. Before we discuss the tasks completed in our labs using robotics, let's first appreciate the broader context of how robotics is becoming increasingly indispensable in various industries. From manufacturing to healthcare, robotics is transforming the way tasks are accomplished, streamlining processes, and pushing the boundaries of what's possible. Exploring the convergence of technology, engineering, and artificial intelligence, robotics continuously push the boundaries of innovation. Today, we'll explore how this cutting-edge technology is making waves across the various industries, revolutionizing the way we work and interact with machines. With this being said, now let's explore the specifics of our activities in the labs. The primary goal of Lab 1 was to get ourselves acquaintance with the Dobot, which is a versatile robotic arm. We learned the basics of Dobot positioning, set up program flows, and completed tasks using the robot arm's coordinates and code-driven commands.
Transitioning to Lab 2, we explored the extensive functionalities of our Dobot in more detail. We explored integrating I/O sensors, set up a conveyor belt system, and even dabbled in image processing and feature matching. We created templates, calibrated the system, extracted colors, and found objects of specific colors, all with the incredible precision of our Dobot. In Lab 3, we enhanced our technical expertise and laid the foundation for synchronized operations between multiple Dobots. For the Dobots to successfully communicate with one another, each group needed to make sure that their own Dobot could perform on its own with no mistakes. We experienced various challenges, and we encountered moments where the Dobot didn't quite cooperate. We quickly learned that Dobot calibration was very important, and having an incorrect calibration file would significantly change the coordinates of our Dobot position. Additionally, this lab relied on precise feature matching, shape and color recognition, and the ability to relocate shapes to their designated positions and angles.
For task 1, we needed to locate and move green letters to spell out the word bus for our partner group's Dobot. Task 1 used the color identification and repositioning methods we used in the previous labs. Task 2 required shape and feature recognition, angle matching, and precise placements that we learned from the previous labs to complete a puzzle. Finally, we put what we learned in all 3 labs and through our failed trials together, and were able to complete both tasks. In the end, we were able to successfully complete the puzzle with our Dobot. After numerous attempts, we're proud to present the successful completion of both tasks, showcasing the capabilities of our Dobot. In today's dynamic landscape where technological advancements shape the future, robotics stands as a driving force behind industry evolution. These 3 labs showed the possibilities that robotics offers on a smaller hands-on scale. While much bigger and more precise robots are used in industrial spaces, the Dobot serves as a versatile and dynamic tool, providing a platform for experimentation and innovation.